Beneath the surface of the Pacific Ocean, the largest body of water on Earth, lies a world that most humans will never see. It covers more than a third of our planet's surface. Its deepest point plunges nearly 11 kilometers down. And within this vast, cold, pressurized darkness, life has found a way, not just to survive, but to become extraordinary. What you are about to witness are not the gentle creatures of a nature calendar. These are the ocean's true giants, masters of strategy, camouflage, intelligence, and raw, brutal power. Each one shaped by millions of years of evolution into something almost impossible to believe. This is the wild Pacific, and it does not forgive weakness. At the top of the ocean's food chain sits a creature that hunts not with brute force alone, but with intelligence, communication, and coordinated military precision, the orca, also called the killer whale, though it is not a whale at all. It is the largest member of the dolphin family. Orcas live in family groups called pods, and here is what makes them truly terrifying. They teach each other. A technique perfected by one pod can be passed down through generations like a cultural tradition. One such technique is the wave wash. When a seal rests on a floating ice floe, the pod lines up in formation. Together, they generate a powerful wave, perfectly timed, perfectly aimed, that washes the seal directly into their waiting mouths. No other marine predator hunts this way. No other marine predator plans ahead this way. Scientists have observed orcas coordinating attacks in ways that rival the tactical thinking of wolves or even humans. They call to each other using complex dialects. Each pod has its own unique set of sounds, sounds that are learned, not instinct, sounds that are, in every meaningful sense of the word, a language. In the wild Pacific, the orca does not just hunt, it strategizes. 400 million years before the first dinosaur walked the earth, sharks were already here. And in all that time, across every mass extinction, every shift in climate, every reshaping of the continents, the shark's basic design has barely changed because it does not need to. It is already perfect. The great white shark can grow to 6 meters in length. It can detect a single drop of blood diluted across 5 million liters of seawater. It can sense the electromagnetic fields generated by the beating hearts of prey hidden beneath the sand. And when it strikes, it does so at speeds exceeding 50 kilometers per hour, launching its entire body clear out of the water in a vertical breach. But the great white is not the mindless killing machine of popular myth. Research shows it is a careful, patient hunter. It surveys its target from below, often circling for minutes before committing to a strike. It learns the behavior of its prey. It avoids unnecessary risk. In waters off South Africa and California, individual great whites have been tracked returning to the same hunting grounds year after year, navigating across thousands of open ocean with an accuracy that still puzzles scientists. 400 million years of practice, and still nothing hunts quite like the great white. Forget everything you think you know about intelligence, because the octopus has evolved it in a completely different way. It has 9 brains, 1 central brain, and 1 mini brain inside each of its 8 arms. Each arm can taste, touch, and make decisions independently without waiting for instructions from the center. It has 3 hearts. Its blood is blue, colored by copper rather than iron. and it can change the color, texture, and pattern of its skin in under 0.2 of a second, making it effectively invisible against almost any background. The octopus has been observed using tools. It collects coconut shell halves and carries them across the seabed for later use as shelter. It has been filmed escaping aquarium tanks, raiding neighboring tanks for food, and navigating complex mazes, all while having a brain the size of a walnut and a lifespan of just 3 years. And then there is the Pacific giant octopus mother. When she lays her eggs, she guards them without leaving for up to 7 months. She stops eating entirely. She fans them with her arms, cleaning them constantly, ensuring they have enough oxygen. By the time they hatch, she has used every last reserve of energy she had. She dies so they can live. Intelligence in the ocean does not look the way we expect it to. Sometimes it looks like this. Every year, along the coastlines of the Pacific, one of the greatest spectacles on Earth takes place. Billions of sardines, small, silver, individually defenseless, gather into a single mass so enormous it can be tracked from space. Alone, a sardine is nothing. Together, they become something else entirely, a superorganism, a living, breathing, shape-shifting creature made of millions of individual parts, each one responding to its neighbor in milliseconds, forming and reforming into tight defensive spheres called bait balls that baffle and confuse even the most experienced predators. But the predators come anyway. Dolphins corral the sardines from below. Cape gannets dive from 30 meters above the surface at speeds of 90 kilometers per hour, hitting the water like living arrows. Sharks circle from the outside, taking opportunistic runs through the mass. Whales lunge with open mouths, filtering thousands of fish in a single pass. And still, the sardines do not scatter. They hold formation. They respond. They adapt. No individual is in charge. There is no leader giving orders. The intelligence of the bait ball is distributed across every single fish within it, a form of collective cognition that computer scientists are now studying to improve the behavior of AI systems and robot swarms. The wild Pacific is not simply a place of violence and survival. It is a place of staggering, almost incomprehensible complexity. Every creature here, from the apex predator to the smallest schooling fish, is the product of millions of years of problem solving. The ocean does not have favorites. It only has solutions. And life, in all its brutal, beautiful, endlessly inventive forms, keeps finding them.